This is Zane, and I'm doing my linear function video. Alright, start off what we can see. Alright, so we have a wildlife facility sells newborn rhinos and gazelles to conservations. R represents the number of rhinos sold yearly, and G represents the number of gazelles sold yearly. The facility makes $4,400 per baby rhino and $2,000 per baby gazelle. So first, we need to write our objective function. So that will be green. Alright, I'm getting on my notes here. Alright, so we have Z, which is going to be the total profit that they're going to make. Then we have the amount per rhino, which is $4,400 per rhino. R represents rhino. And then we can add on the 2,000 per gazelle, which is G. It's kind of cut in there. Alright, and that would be our objective function that we could come back to. Alright, step 2, we need to figure out our constraints and write functions for each constraint. So our first constraint is there can be no more than 12 animals total. That'll be sold per year. So we can add the rhinos and the gazelles have to be less than or equal to 12. And this will be per year. So this is our first constraint. Our second constraint, the care of yearly cost. So it's $2,000 per rhino and $1,000 per gazelle. But the max per year is $30,000. So first, we write 2,000 R, which represents the cost per rhino. And then we add on the 1,000 per gazelle. This is the cost per each. And now we figure out the max. So we know that it has to be less than or equal to 30,000. Alright, and now we figure out our third constraint, which there's only 24 units of space available for each of these animals. So we have 3 units of space per rhino. So same thing, 3R, and 1 unit of space per gazelle. So now we add on 1G, which represents the gazelle. And we know that has to be less than or equal to 24 units of available space. Alright, lastly, a pretty basic one. We know that we cannot sell less than the amount that we already have. So we can't have any negative numbers. So we do there, R has to be greater than or equal to 0. And G has to be greater than or equal to 0. Alright, now we move on to graphing the constraints. So we can start with the most simple one. We can go back to here and graph, and we know that it has to be greater than or equal to 0 and greater than or equal to 0. So all we do is draw a little line right here, knowing that it cannot be 0. Now we can come back up here and we can start with the first one. Trying to get my notes here. Alright, so we know that R plus 6 plus G, has to be less than or equal to 12. That's our first constraint. And so all we do is set the variable equal to 0 and solve for the other. So what we're going to do is set R equal to 0 and then keep G. And then we're going to change this to an equal sign. So now we know that G is equal to 12 when R is equal to 0. So our first point, R, which is 0, and G, which is 12. And we can do that vice versa. Just replace the R, and all you have to do is write your next point, which R will be equal to 12, and G will be equal to 0. So now, when we graph that, put that 1 right there. When we graph that, we go 0 all the way up to 12, put a dot there, 12 all the way to 0, and we draw a line. Pretty straight. Alright, now we can move on to our second constraint. Second constraint, we bring this one over here, same thing, a little more complicated. 2,000 per rhino plus 1,000 per gazelle. And then, of course, we change this to an equal sign, 30,000. Same thing, we set this one equal to 0, so this will end up being 0 plus 1,000 G. And then that'll be equal to 30,000. So we can derive our points. We know that when R is equal to 0, G is equal to 30, just by division. Same thing, we can set G equal to 0. Plus 0, since we know that turns 0, equal to 30,000. Alright, and then we can divide 30,000 by 2,000, which is just 15. So that way, when we know G is equal to 0, we'll write that out. When G is equal to 0, R is equal to 15. So, to graph this point and this point, just go 0, all the way up to 30, way up there, and then 15, 0, just like right here. Alright, now we try and draw a line to the best of our ability. Right there. That's a rough estimate of how it's going to look. Alright, and now we can move on to our third one. If I move quickly here, go over here. Okay. Alright, our third one, 3R plus G is equal to 24. Now we just replace the zeros. Alright, so 0 plus G equals 24. So we know when R is equal to 0, G is equal to 24. Alright, and then when we take G and put it as 0, then we can do simple division and figure out that R is equal to 8 when G is equal to 0. And then when we graph that, that'll be up here, 12, and then 8, 0. We're trying to draw a line down here. So far we have this line, this line, this line, and this line. Alright, and then for this one, the fourth one, to be a little bit more complicated, or a little less complicated actually. R is less than or equal to 8. So you can't really set G equal to 0. So R is going to be, we'll put 4 over here. R is automatically going to be equal to 8. So all we do is come up here, put a dot there. When R is equal to 8, we're just going to do a vertical line. We know that it can't be any of those variables. Alright, and then we set G. Then we set G equal to 12. Alright, there. 12, we got lost. Alright, and when it's 12, then we just draw a simple vertical line like that. We know that it can't be any of those numbers. So, our highest number. Alright, well, I made it a little bit more complicated than I need to. So what I'm going to do, I'm going to eliminate one of the variables, or the constraints. Sorry about that. Alright, I'm going to eliminate number 4 because I don't really want to deal with straight lines because that's going to make it a lot more complicated than I thought. So what I'm going to do is I'm going to go back and we're going to go and find the 4 points. So that'll be this one, and these 2 right here. And then from there, we can find our maximum value for the facility. Alright, so I'm going to eliminate this right here, just so I have some space. Alright, so we're going to take our objective function. Alright, we're going to take in this point, this point, this point, and this point. So our first point, 0, 12. All we're going to do is plug in the answers. So when we plug in 4,000 times 0, obviously that gets nothing. And then 2,000 times 12. From there we get 24,000, which is a pretty big number. Alright, and then we're going to take in our second point, 8, 0. Alright, and then we're going to do the same thing, plug it in, 4,400 times 8 plus 2,000 times 0 is actually going to be bigger. It's going to be 35,000 200. All right, and then we have these 2 points right here, which are going to be our minimum values. So I'm just going to outline this here. All right, we have 0, 1. All we're going to do 4,400, 0 plus 2,000. You just multiply it by the 1. And you're going to get 2,000. So obviously that's not going to be as much as the other 2 variables. All right, then we're going to take the same thing, vice versa. 1, 0. Run out of room here. 4,400 times 1 plus 2,000 times 0, which is just cancel this out, is equal to 4,400. So in conclusion, we're going to look at this variable right here. We're going to go back and see, out of all 4 of these, this one yields the most money. We're going to go back, we find that this point is at 8, 0. So effectively, this is going to be the best combination of animals, of rhinos and gazelles, in order to get the most profit. I didn't calculate or consider this one right here because it's basically the same and I didn't think about it that far ahead. So I'm just going to take this point instead. All right, thank you for watching my video, and hopefully it's not too long. Hopefully I got all the information in there, and thank you.